Hey everyone, welcome to your crash course in factoring. Now, factoring has a lot to it, and we do not have that much time left in the year to learn it. So, this is all the information at once. So, just bear with me, I know you can do it. So, factoring. A key to factoring is dividing out the greatest common factor, or GCF. This requires you to divide out the largest number in variable evenly from everything in the polynomial. So we've talked about adding, subtracting, and multiplying. This is kind of the form of dividing. What we're doing is we're taking something that's a polynomial, like more terms, and then trying to combine into less terms. So if you're just factoring the greatest common factor, what you want to do is find the largest number you can divide from all numbers in the polynomial. So I have my example right here of 4x to the fourth plus 8x to the third plus 12x squared. The largest number that can be divided from 4, 8, and 12 is 4. So yes, 2 can go into each and every one of them, but that is not the greatest common factor. We want something that's the largest number, and 4 is the largest number. Great, now we can move on to step 2. Step 2 is find the largest amount of variables you can remove. If not all the variables have all the terms have variables, the step is not possible. So in this one, it is possible. So we have 4x to the fourth, x to the third, 2x or 12x to the second power. Each of these terms has a variable with it. So we have a x and x and x, all the same, perfect. And then we have to the fourth power, to the third power, and to the second power. Each of these have at least to the second power. So that means that I can remove x to the second power. So it really helps that if you see they all have variables with it, find the smallest one, and that's what you can take out. But if they don't have all variables, then you cannot do that. And step 3, divide what you factored out by everything. What you factored out should go in front and the new polynomial inside parentheses. So I said that I can divide out a 4, so I divided everything by 4. 4 divided by 4 is 1, 8 divided by 4 is 2, and 12 divided by 4 is 3. And then I factored out x squared. X to the fourth divided by x squared, subtractor powers just like in power quotient, and we get x to the second power. X to the third divided by x to the second is just going to be x, and x to the second divided by x to the second is nothing at all. So what I did was I rewrote what I factored out in front, so 4x squared, and then I rewrote what I now have, which is x squared plus 2x plus 3 in parentheses. And you're done. So that's factoring out greatest common factor. And you will do this for anything besides the next few examples that I'm going to give you. So pretty much everything besides proper trinomials, which is where we're going to next, after a few examples, of course. So greatest common factoring practice. So I have 7x squared plus x. Taking a look in step 1, the numbers in front. I have a 7 and a 1. There's no number besides 1 that can be divided by 7 and 1. So I know that I can divide a 1 from it. I also see that I have x squared and x. They're both variables. They both have a power of at least 1, so I can divide x to the first power from that as well. 7x to the second power divided by 1x to the first power is just going to give me 7x. And x to the first power divided by x to the first power is just going to give me 1. So my final answer for that will be 7x to the first power. And now instead of a box, though, we're going to put that in parentheses with an x in front. So I'm going to rewrite that so it looks a little nicer. So again, what we divided out in front, and then what we now have inside the parentheses. There you go, that's a better answer. Now in this second example, I have a 2x squared plus 4x plus 6. Well, I see there's a 2, 4, and a 6. The greatest common factor that I can divide those by is 2. 2, 4, and 6 can be divided by 2. There's no other number that can go into all of them. And now I'm going to see if I can take out a variable. I have an x squared, an x, and then no x at all. Since this doesn't have an x at all, I can't divide by a variable. So the only thing I can divide by is 2. So I'm going to take what I divide by, put it in front of the parentheses. 2x squared divided by 2 will just give us x squared. 4x divided by 2 is just going to be 2x. And 6 divided by 2 is 3. And I have my answer. There we go. Okay, now we have x plus 3. Well, there's a 1 in front of this x, even though it's not written there. And the greatest common factor that I can divide by 1 and 3 is just 1. Sometimes you need to divide by just 1, and that's okay. I can't divide by an x because that 3 doesn't have an x. So that's my answer. I have a 1 in front and x plus 3. So just because it doesn't look like anything can be divided out of it, it actually can't. 1 is definitely a solution for that. And our last example is 6x plus 15. I can divide the greatest common factor, which is going to be 3. I can't put an x down here or on here because that 15 doesn't have an x. So all I'm going to do is take out 3 and divide it to get 2x plus 5. And there you go. Now we're going to make it a little bit more difficult. So always try factoring out the greatest common factor first before you do any of the rest of these steps. That is a great hint. It saves you time and it makes sure that you get as accurate as an answer as you can. So factoring is not just finding the greatest common factor. Instead, you have to sometimes factor trinomials. So remember, trinomials are the 3 terms. So if you have a trinomial in the form of x squared plus bx plus c, these are the steps that you do. Now, what does that mean? That means that if there's a number 1 in front of x squared, so they won't write the number 1, but it'll be blank. So if it's x squared plus something x plus something, these are the steps that you will do. So here we go. Step 1, label each number of the trinomial. A is the number in front of x squared. For this process and this one only, it should be 1. B is the number in front of x, and c is that last number. So in my example, I have x squared plus 5x minus 36. A should be the number in front of x squared, which in this example is 1. B is 5, because it's in front of x. And c is that last number, which is negative 36. Okay, let's keep going. Step 2, create a chart shown on the left and list the factors of c. So what numbers multiply to equal c? So in our example, we had c is equal to negative 36. So what I did was I created a chart. I have c on my left, b on my right. We'll come to this b in just a moment. But let's take a look at our factors. I know that 1 times 36 is going to equal 36. 2 times 18 will equal to 36. 3 times 12 will equal to 36, and 4 times 9 will equal to 36. We'll worry about that negative in just a bit, but what you need to figure out is what can be multiplied together in order to equal your C. Now, that might require you to use your calculator, think outside the box. It's really important for you to make sure you list all the factors just in case you miss something, okay? So here we go, next step. Step 3, from your listed factors, find the pair that will add up to B. So negative signs are needed if C or B are negative. So we have a C that's negative, that's 36, negative 36. And we want to find which set of these factors equals to 5. Now, 1 plus 36 is not going to equal 5. And if we even put subtraction problems in it, or negative signs in it, -1 plus 36 is still not equal to 5. And you can switch it around, but either way, it's not equal to 5. 2 and 18, again, adding them won't equal 5. Putting negatives in there won't equal 5. So we got to move on. 3 and 12, same thing. But if we look at 4 and 9, yes, 4 plus 9 does not equal 5. However, just like I said over here, you can put negatives in, and we actually need to because C is equal to 36, or negative 36. We need to find something that will multiply to negative 36, but add up to 5. And if we put a negative in front of 4, then we can do that because negative 4 times 9 is negative 36. And negative 4 plus 9 is equal to 5. A lot of this is just experimenting, figuring out which combination is going to work out the best. Each problem is different, so I really can't say one way or another, but I will say that if C or B is negative, you're going to have to find a negative in there somewhere. And then step 4, use the two factors found in the table to write the two binomials. So what that means is you put an x in front of each number and then parentheses around them. And you're done. Those are your factors. So again, this is the process if there's no number in front of x squared. Things are going to get a little more complicated when we go through those examples. But the answer to my problem is x minus 4 and x plus 9. We took my negative 4, put an x in front of it, put parentheses around it. We took the positive 9, put an x in front of it, and put parentheses around it. And you have your factors. So let's take a look at a couple other examples. So we have x squared plus 9x plus 18. So I'm going to do my first step, which is label my numbers. So I know a is equal to 1, b is equal to 9, and c is equal to 18. Perfect. Now I'm going to create my chart. So I have my C over here, which is 18. And we're going to try and find those factors that add up to our B, which is 9. So I know the factors of 18 are 1 times 18, 2 times 9, and 3 times 6. Now, which one of these add up to 9? So 1 and 18, not really. 2 and 9, well, there's a 9 already there, so that's not going to work. What about 3 and 6? Hey, 3 plus 6 is equal to 9, and 3 times 6 is equal to 18. Perfect. So my solution is going to be x plus 3 and x plus 6. Yay, you're all done. Let's try one more. So we have x squared minus 4x minus 21. Again, my a is equal to 1. My b is now equal to negative 4. And my c is now equal to negative 21. So I'm going to create my chart again. I have negative 21 to find the factors of, and I want to add that up to a negative 4. I know that the factors of 21 are going to be 1 times 21 and 3 times 7. So I need to equal negative 4. I see a negative in there, so that must mean I have to have a negative somewhere. So 1 and 21, that doesn't work. But 3 and 7, if I take negative 7 and add it to 3, I will get negative 4. And negative 7 times 3 is negative 21 as well. Perfect. So I have x minus 7 and x plus 3 as my answers. Yay! I'm hoping you find this as easy as it can be. I know it's a lot for you to take in. We do have one more section we have to do, but you're doing amazing, so keep it up. Okay, here's the next problem. What if there is that number in front of x squared? So factoring trinomials in the form of ax squared plus bx plus c. There is a number in front of x squared. Oh no, what do we do? we're going to have to do a few more steps. So here we go. Step 1, identify the numbers for A, B, and C. This time A should have a number other than 1. So if this is a 1, go back a page and do those steps. Save yourself some time. If not, then you can do it this way. You technically can use these steps in order to do any trinomials or factor any trinomials. It's just more work, so I'm trying to save you some time. So in this example of 2x squared plus 11x plus 15, my A is equal to 2, my B is equal to 11, and my C is equal to 15. Gotta make that 11. There we go. So now that I have that, I am going to go on to step 2, which says create a table like the one on the left, multiplying A and C, and list the factors. So in last example, we only had C here. Now there's a number in front of A, so we need to multiply A and C together. And 2 times 15 is equal to 30. So I'm going to find my factors of 30. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Same type of thing as last time, we're just adding that extra step of multiplying by A. Okay, here we go, next step. Step 3, find the factors that add up to B. Remember that to use negatives if A times C or B are negative. So we know that our B is 11. We need to find factors that will add up to a positive 11. 1 and 30 doesn't, 2 and 15 doesn't, and 3 and 10 don't. Whether you add or subtract, nothing is going to equal to 11. But 5 and 6 do, because 5 plus 6 is equal to 11. Now, this is where things get more complicated. You can't put x equals 5 and x equals 6 because that's not the solution. It's not going to reflect that A times C. So what you need to do is continue on with these steps. Step 4, rewrite the trinomial as a polynomial with 4 terms by replacing the middle term with the 2 factors from the table. It doesn't matter what order you put the terms. So you found the 2 terms or the 2 numbers that multiply to A times C and add up to B. Now you need to replace B x with those terms. So I had 2x squared plus 11x plus 15. I took my 2 terms, which is 5 plus 6, and I replaced 11x with them. So I now have 2x squared plus 5x plus 6x plus 15. I know it looks a little complicated, but the more you practice with this, the better. Okay, step 5, put parentheses around the first 2 terms and the last 2 terms. Then find the greatest common factor for each set of parentheses. So notice how everything's kind of circling back. You're using all the steps that I taught you at the beginning of this video and bringing it all to use in this example. So I had 2x squared plus 5x, and I put those in parentheses. And then I had my last 2 terms of 6x plus 15. Now, in that first set of terms, so 2x squared plus 5x, I discovered that the greatest common factor was 1x. I know it's 1x because I can't divide any other number by 2 and 5 other than 1. And I know I can take out an x because I have x squared and an x right here. So my greatest common factor is 1x. In the second set of parentheses, I see that I have a 6 and I have a 15. 6 and 15 can both be divided by 3. But since this 15 doesn't have an x, I can't take out an x. So my greatest common factor can only be 3. Step 6, divide out the greatest common factor. If you did this correctly, you should have the same binomial after dividing. And let's take a look at how I did that. So I said my greatest common factor for the first set of parentheses was 1x. 2x squared divided by 1x is 2x squared. And 5x divided by x is going to just be x. And I put what I took out in front of the parentheses, like I said you had to do before. So right now I have x times 2x plus 5. Now I looked at my second set, 6x plus 15. I divided both of them by 3 to get 2x plus 5. Notice how what's in parentheses in the second part is the same as the first part. You should always, always, always get that. If you didn't, then you did something wrong. And then, of course, I took my greatest common factor and I put it in front of the parentheses. Oh, we're almost there. You guys are doing amazing. So, step 7, rewrite what's in the parentheses once. This is your first factor. Then combine the greatest common factors to create the other factor. So that's a lot of factors in there. Let's see what I mean. So 2x plus 5. We had that the same thing in the parentheses. That is one of my factors. So 2x plus 5 is one of my answers right here. The other answer I'm going to get by combining what I took out, my x and my positive 3. So I took the x and the positive 3 and combined them together in order to get my second factor of x plus 3. And I'm all done. That's factoring. I know when I say all done, it seems like it was a long process, and it is. It is a tough task, but I know you can all do it. So let's take a look at another example. So I have 2x squared minus x minus 21. So I'm going to identify my a, which is 2, my b, which is negative 1, and my c, which is negative 21. Great. So now I'm going to create my table. I need a times c right here, and that has to add up to b. Well, 2 times negative 21 is going to be negative 42. And my b, of course, is negative 1. So my factors of negative 42 are going to be 1 and 42, 2 and 21, 3 and 14, and 6 and 7. Well, taking a look at that, I need to find out what two factors add up to negative 1. Well, the first 3 I can tell automatically are not going to be the answer because they're not close together, and I need to equal negative 1. But 6 and 7 look good. So what I'm going to do is I'm going to take my positive 6 and add it with negative 7 in order to get negative 1. That's perfect because 6 times negative 7 is negative 42, but 6 plus negative 7 is negative 1. Okay, now here's where things get a little different from last time. So we have 2x squared, and now instead of my minus x, I'm going to write plus 6x minus 7x minus 21. Okay, so again, I replace that negative 1x with plus 6 minus 7x. And if you added those, you still get negative 1x. So everything should be good. Putting parentheses around my first 2 and my last 2 terms. And I'm going to find that greatest common factor. Over here in the first set, I have a 2 and a 6. Well, I know those can be divided by 2. I also see that both of these have x's. So I can take out an x as well. Here's a little hint. You should be able to take out an x in the first set of parentheses, but never in the second set of parentheses. Okay, let's look at the second one. I have a negative 7 and a negative 21. Always trying to take out a negative, especially if this first term is a negative. So if you see that negative there, always make sure you're taking out a negative. And I can take out a negative 7 on both of these. Perfect. So here, let's do some dividing. I have my 2x in front. 2x squared divided by 2x is going to equal x. 6x divided by 2x is equal to 3. Now I'm taking out that negative 7. Negative 7x divided by negative 7 is a positive x. And negative 21 divided by negative 7 is a positive 3. Yay! I did things right. I have the same thing inside the parentheses. which is x plus 3. So that will be one of my answers. And my other answer is what I took out, my 2x minus 7. And I am all done. Yay! Now, one more thing before I leave ya. Some people, some worksheets are going to ask you to find solution to factors. It's really important to know that factors are polynomials. They have operation signs of adding and subtracting in them and a variable. What they're looking for in solutions are numbers. So 2 numbers, not adding, not subtracting, no x's, nothing, just numbers. And to find those solutions, you need to set the factors equal to 0 and solve for x. So here are a couple of our examples. We had x minus 4 and x plus 9. So I'm going to take each of these terms, set them equal to 0. And I'm going to solve for x. To get that x by itself, I'm adding 4 on both sides. And one of my solutions is 4. Same thing with the other side. Need to do the opposite operation, which in this case is subtraction. And I have my second solution. That's it. These are the solutions. They're one number. There's not a adding, subtracting, multiplying, no variables besides what they're equal to. Cool. Let's take a look at our next one. 2x plus 5, setting that equal to 0, and x plus 3. So this is a 2-step problem, so I'm going to take the 5 and subtract it on both sides. And then I'm going to divide by 2. And my first solution is negative 5 halves. Now, same thing over here. Subtracting 3 on both sides. And I have x equals negative 3. So my 2 solutions are x equals negative 5 halves and x equals negative 3. 2 solutions, 2 numbers. That's all I need for solutions. Now, sometimes you see something that looks like this, where they're not 2 sets in parentheses, and you just have that random x in front. That's okay. Set it equal to 0, just like the instruction says. And look at that. You already have one of your solutions. X is equal to 0. Perfect. Now you just have to find the other one. Yay! And you're done. I know that is a whole lot for you to get in one video, but I'm so proud of you for sticking out through this. I will say that all factoring is just the opposite of what you've done. So if you take what you factored out, so let's go back to our previous example. Nope, one more. I'll find it eventually. There we go. So for example, or this one right here. So x plus 3 and x plus 6. If you took these factors and you FOILed them, you should get this answer. So you can check yourself every single time when you're factoring. Just do the opposite. Just do distributive property, FOILing, whatever you need to in order to get back to your solution. So it really is the opposite of what you are learning. So always check yourself. Make sure that you are looking at these notes. It's a lot of them, but you are doing great. So thank you, thank you, thank you. Let me know if you have any questions.